Okay guys, so this is Jerry's instrument cluster from the last video, which I believe is number 3 in the series, so this will be number 4. So, he mentioned to me, back when he sent it to me, that the temperature gauge, the tachometer, the fuel gauge were not working. Actually, neither were the lights in the middle here either. And initially in the video that I did a couple days ago, I had taken just a real quick look at the circuit board on the back of this thing to find out if I could see why. I couldn't see anything at that time. Now, of course, I knew he was missing the voltage regulator, which is right down here. So I grabbed that from another one of my spare instrument clusters, and I popped that in there. Even after that, I hooked this spare UPS battery from the very first video that I did up to it, which is still registering a nice usable 13 volts, and hooked it up to the appropriate terminals on the connector here, and nothing. So I then switched it to the terminals that power the clock, and I got the clock to turn on. Now this is the original clock. I actually can do that again for you guys so you can see that the clock works, and then I can switch it so that you can see that everything else does not work. Now, of course, I've done my homework on this. I know why it doesn't work, but I'll leave that for later. So these are all labeled. They're all in German. One of them is Masse 31. I think I'm saying that wrong, probably. That means ground. Circuit number 31 in German and most European vehicles is ground. And then over here at the very opposite end of the scale, you have plus 15, which is ignition on in German and other European vehicles. And then in the middle somewhere here, pin 6 is Uhr, which is hour, which I assume means clock, and that assumption was correct. So let's hook this up to ground. Here's ground, and then we'll do Uhr. I think I'm getting a good connection there. So got that hooked up. Now my battery's over here. Hopefully I don't get in the way of the cameras. So negative and positive. It looks like we got a bad connection there. These alligator clips aren't the greatest. I have to flip it upside down. Yeah. Oh. That should be the one right there. Okay, that's hooked up. Try again. There we go. Clock works. You can see that. Now, I don't know why the clock resets to 103, but whatever. I don't care. It's working. So that's good. Now if we move this over to the very end over here, plus 15, we can see that this actually, when I do this, it should behave as though the car was starting up. So you should have some flashing lights in the middle. The gauges won't move anywhere, but this LED in the coolant temperature gauge should flash as well. So let's see what happens here. Nothing. Okay. Now we'll just jiggle these, make sure that they've got a good connection. That happened before. Still nothing. Now I've taken this, I flipped it over. I'm gonna be careful not to bend any needles, but on the back here we have some pretty intense circuitry. Nothing by today's standards. The back of a modern instrument cluster would probably look way different, and all of this circuitry might actually be in a consolidated integrated circuit, little chip, or it could be just built into the back of the gauges and stuff. I haven't seen any other instrument clusters aside from this era that have this cellophane type material. So I decided that in order to diagnose this, I was going to trace the leads. So I trace ground, and it goes to all the necessary places without any breaks. And actually, I know that ground is working because when I had ground hooked up and I had UR hooked up, the clock worked. So that means we know we have a good ground connection and a good clock connection. So that means the issue must be with this plus 15 right here. So we're going to trace plus 15 around the edge. It goes down here, comes around the corner, and it didn't take me long to notice that right there, I don't know if you guys can see this, you probably can't because it's so tiny, but right, let me get this thing to focus. Okay, right there, there's a break in that trace, and that is the plus 15 trace. It goes all the way over, and the only place it branches to is the positive leg of the voltage regulator. So that's this guy here, that's the voltage regulator. There's the positive side of it. So we trace this around. It also goes over here to what appears to be the back of the speedometer, because that's what this connector is. And then it probably branches out to some of the other instruments here as well. So, how am I going to fix it? Well, I have the option of not fixing it and using one of my other spare speedometer clusters, but the problem with that is Jerry's is a new enough one to where his cluster doesn't have this fancy upshift light here, because they stopped doing that in, I think, 87 or 86, and his is an 89 if I recall correctly. So rather than change the appearance of his instrument cluster, I figured maybe I can repair this and make this one work again, and that way I get to keep my spare as well. So what I'm going to do is repair this. So now that I've decided I want to repair this, I have two ways to repair it. I can either fix this little broken connection here, or I can literally just solder a wire from here to here that bypasses that whole trace. Now, this is a cellophane circuit board, so any amount of heat from a soldering iron will probably melt it. Nothing on here is soldered. The only thing, the only type of connection on this is screw terminal or crimps, which it's marvelous that these things haven't actually failed over time, but yeah, there's no solder connections on here at all. So I'm a little wary on soldering it. I might try it first, and if it hurts the trace even more, well, then I know that I can't solder it. But what I can do as a backup plan is solder a wire between here and here. So I'm going to get set up here and get ready to try to repair that trace, and we'll see how it goes. Hopefully I don't melt anything. So I'm going to take all these screws off here, and so stay tuned. I'll be right back so that I have just the cellophane to work with. So there's our tachometer separated. I've actually never had a cluster this far apart before. Usually it's not necessary. And so this should just kind of slide out. That's our coolant temperature gauge. Put that aside. Here's the remaining assembly that we have to work with. So this is clipped on, so I have to be careful with this not to tear any of this plastic as I'm working with it. Got it. And one more. One side, other side. Okay. Should now be able to remove the LEDs on top, I hope. Let's see what happens here. This is a new one for me. So it's coming off. There we go. One side. There we go. Perfect. Fantastic. So those of you who didn't know, the headlight, or the high beam LED, is not actually, it appears, not actually an LED. It's just a little incandescent bulb with a blue cap on top of it. So that's kind of neat. Is it replaceable? I don't know. No, it is an LED. It's, who knows what? Oh, it's incandescent. Crazy. So they didn't have blue LEDs when this was made, so they had to use a substitute, and that's a so we gotta make sure we don't screw up the orientation of those. That's that way, that way. It's like the longer legs are to the left. Same with this one. Okay, now this should just kind of pop free. I hope. Never know for sure. Yeah, it's coming free. Here we go. Oh yeah, and the clock, of course, I gotta take that out. It's really quite impressive how many pieces actually make this assembly up. Okay, so this is all separate now. And now we have just our cellophane to work with. Fancy schmancy circuit board from the 1980s. I'm going to get my soldering stuff. I'm going to arrange this stuff so that I have room to actually work. I'll be right back. Okay, so this is heating up now. I've got my little grippy things holding this in place so I can work on it. Got a little bit of solder, and we're gonna fix this thing, but we're gonna test in an inconspicuous area, as they always say, just to make sure that this isn't gonna completely destroy this cellophane. So while I'm waiting for this to heat up, it's getting there already, actually. Awesome. Let's see how badly this destroys the cellophane. It puts holes in it pretty quick. Okay, so I'm gonna go grab my tinning. So this is gonna have to be a really, really fragile operation. Really quick with the soldering iron. Now I have a heat sink here as well. I might benefit from using near the area, if nothing else, just to keep it straight. So before we get that all set up, I'm actually going to scratch a little bit of plastic away from the area. a sharper knife for that, and my X-Acto. We'll see how this works. Don't worry, Jerry, if I screw this up, I've got a spare cluster for you. It's part of learning on this channel, screwing up. Alright. There's one. One half. Alright, both sides of the break are now accessible to solder. This is going to be interesting. I've never soldered something this easy to melt before. Well, here we go. Make sure we got this all tinned up. It's very fragile, but I got it. You guys probably didn't see a whole lot of that, but I think I just got it. So let's verify. Now I have my voltmeter over here, so I don't want to burn myself. Let's not be like Roy and cause a fire. So I've got my fluke meter here, put it into continuity mode. So we got that working. Now the trick, the fix, is to make sure that this pin is in contact with this pin over here. So let's try it out. We're good. I fixed it. Okay. Now, I don't know how long it's going to last, Jerry, but that's fresh solder where there was no solder anywhere before. So I'm guessing it doesn't look like it got a cold joint either, which is good. Cold solder joint. So it looks like this should work again. Now let's put everything back together and try it out. So stay tuned. Now I will be having to take this apart again to get to the needle, but such is life. This is just for testing purposes, so. And that should be good. Alright, let's just check to make sure that that's still good. It's got some kind of connection. I wonder if that broke again. Oh, we're good. Okay. So after this is all confirmed working, I'll put a dab of liquid electrical tape on this spot, or maybe conformal coating, just to prevent anything from touching that, because that is positive. If anything touches that on the body of the car or any wires behind it, we could have a quite a bit of an issue, a short going on there. So let's get this tested, and then I can do that, and then we can call this a working cluster again, and Jerry will have the original cluster from his car just working this time. So alright, so ground again goes here, should be good. Plus 15 goes here. That should be good. Alright, so if I did this the right way, we should have some blinking lights going on here when I hook this up. Yeah, we got that one working. And I think that's all we need to confirm that it's working. Because the other ones should all be on the same circuit. So, great success. We're good. It's fixed. Okay. So, what's next in this project? Oh gee, I don't know. Probably painting the needles. So if you'd like to see that, hit subscribe. And if you liked what I did here to fix this circuit board, hit like. And if you didn't really like any of this, hit dislike. And look forward to seeing you next time. Have a good day.